Learning Target 3 says I can factor monic quadratics and solve quadratic equations. Now, just as a reminder, a monic quadratic just means a quadratic where the leading coefficient is 1. So these are quadratics where your very first term is just going to be x squared. It isn't going to be 2x squared or 5x squared or something like that. So we're going to go through a bit of just factoring and a bit of solving equations. So if the directions say factor, that just means we want to break this quadratic into the product of two other expressions. So if it says factor, our answer is going to look like the product of two other expressions. Now, any kind of a monic quadratic is always going to factor into x plus a number times x plus another number. And so what we're going to do is we're going to use a multiplication box to try to figure out what those two expressions are. So we know that our monic quadratic will factor into x plus some number times x plus some other number. We know that when we multiply these two expressions together, and if we simplify and combine any like terms, we should end up getting out x squared minus 6x plus 8. So filling in our multiplication box, we know our x squared is going to go in the top left corner because that comes from multiplying this x by this x. Now we know that our positive 8 is going to go in the bottom right corner because it's going to come from multiplying this number by this number here. So we'll have a positive 8 in the bottom right hand corner. Now, these two other boxes are going to have something times x. And we can tell because they're going to come from having multiplied this x over here by this number up here, whatever it is. And then this term is going to come from multiplying this x up here by this number over here, whatever it is. So we know that these two boxes are going to be some number times x. And our goal is to figure out, well, what would that number have to be? With monic quadratics, we're going to look for two numbers that multiply to make positive 8, which is just this last constant term here, and add to make negative 6, which is this middle term, this middle coefficient here. So we want to figure out two numbers that multiply to make positive 8 and add to make a negative 6. So two numbers that would work would be negative 2 and negative 4. Those multiply to make a positive 8 and they add to make a negative 6. So those are going to be our two numbers that are going to go in front of our x's inside of our multiplication box. And we can fill in the rest of the outside of our multiplication box by sort of thinking about, well, what number would have to go up here to make this box be a negative 2x and this box become an 8. So let's first focus on this box here. That's a negative 2x. This box comes from multiplying this x by this number up here. So if this is a negative 2x and this is an x, this better be a negative 2. Now, down here, if this is a negative 4x, and there's an x up here, and this box comes from multiplying this x by this number, then this number down here better be a negative 4. Now, we're not quite done. The numbers that are out here on our multiplication box, these are the two factors that would multiply out to create something that would simplify down to x squared minus 6x plus 8. So really our final answer is going to be x minus 2 times x minus 4. So number 2 is a little bit trickier. This is an expression x squared minus 16. What's a little bit trickier about this one is just that it doesn't have a middle term, it doesn't have an x term. So whenever I see something like this, I'm always going to rewrite it with that middle term written as plus 0x, because there really is a middle term in there. There are just 0 x's. So there really is a middle term in there, and we just want to write it as 0x. And in that way, we can just follow the same procedure as we have been for our other monic quadratics. So we know that this is going to come from having multiplied something that looks like x plus some number and x plus some other number. So we know that this top left box is going to be our x squared, this bottom right box is going to be our minus 16, and we know that these other two boxes are going to be something times x, for the same reasons that I discussed in the last problem. Now, remembering from the last problem, the two numbers that go in front of these x's, they were two numbers that multiplied to make the constant term and added to make the middle term. So in this case, we need two numbers that multiply to make a negative 16 and that add to make 0. So let's just think about this for a second. If we want two numbers that add to make 0, they better be something like 2 and negative 2, 7 and negative 7, 5 and negative 5. That'll be the only way that we have two numbers that add up to make 0. So we also need them to multiply to make a negative 16. 16 is 4 times 4, so we could use the two numbers negative 4 and positive 4. Those definitely add up to make 0, but they would multiply to make a negative 16. So those are going to be my numbers that go in front of my x's in my multiplication box. Now, I need to fill in the rest of the outside of my multiplication box. So let's see. This box is a negative 4x. That came from multiplying this x by this number up here. So this better be negative 4. This box came from multiplying this number out here by this x up here. So this better be a positive 4. And we can just double check that everything multiplies the way we expect. X times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. 4 times negative 4 is negative 16. And if you were to add up all these terms, notice that the 4x and the negative 4x would be combined to make 0x, and this would all simplify down to x squared minus 16. But our goal was to factor, which means to break it up into the product of two expressions. So our final answer is just going to look like those two factors that we found multiplied together. Now, problem 3 asks you to solve the equation for x. When you see solve the equation for x, that means find the values of x that make this true. So factoring is important in solving quadratic equations, but we don't just stop at factoring. We need to solve for x. So the very first thing you should ever do when you're trying to solve an equation is at least a polynomial equation or a quadratic equation, is to get all the terms over to one side, set equal to 0. So I have my x squared on the left. I like to bring all my terms over to wherever my x squared happens to be. I'm going to do that by subtracting 3x from both sides and subtracting 10 from both sides, and that allows me to move those terms over to the other side of the equation. Now, what I want to do next is I want to factor this quadratic piece. Once I have it factored, I'm going to use the zero product property to solve. So now I need to factor x squared minus 3x minus 10. So I'm going to set up my little multiplication box. Again, this is a monic quadratic, so I know this is going to come from multiplying x plus some number times x plus some other number. So my x squared term is going to go in the top left, my negative 10 will go in the bottom right, and each of these two other terms is going to just be some number times x. Now, as we talked about in the previous problem, the two numbers in front of the x's, we're going to need them to multiply to make -10. We're going to need them to add to make -3. So when I think about these, -5 and +2 would work. So if we do -5 and +2, that'll multiply to make a -10, and it'll add to make a -3. Be careful in these kinds of problems to choose the right one to be negative. It's really easy for someone to just say, oh, 5 and -2, and not realize, wait, that would add to make a +3, and I wanted to add to make a -3, so just be careful there. So I'm going to put my -5 in front of one of my x's. I'm going to put my 2 in front of my other x. And now I'm going to fill in the rest of the outside of my multiplication box. So this -5x came from multiplying this x by this number. So this number up top better be a -5. This box 2x came from multiplying this x by this number. So this better be a 2 out here. So the fully factored form will be x plus 2 times x minus 5 equals 0. Now, we haven't actually finished the problem though, because the question asks us to solve the equation for x. So we're not done until we have actually found the values of x that make this true. So our final step is going to be that we're going to need to use the zero product property to solve for x. So here's what the zero product property says. Whenever you have a product of two different things, at least one of them has to be 0. You can't get 0 by multiplying 2 and -2 or 2 and a half. Like, you can't get 0 by multiplying two numbers that are not 0 together. So if you have two things multiplied together equal to 0, one or both of them needs to be 0. So our two options would be that x plus 2 is 0 or x minus 5 is 0. And now we can just figure out the values of x that make each of these equations true. For the one to the left, solving for x, we get x is -2. And for the one on the right, solving for x, we get x is a +5. So our final answers are -2 and +5. So be careful though to pay attention to the directions. This problem asked us to solve the equation for x. So our final answer should look like two x values. Or in the case of other polynomials, there might be more than two x values. For problems where it asked you just to factor, we were really only looking for, we would give you something that looks like this, and your final answer should look something like this. So just be careful to pay attention to what the directions are asking you to do.